In this video, I will be talking about population proportion. So to get started, I just want to compare it with the previous questions we've done on sample means. So the idea here is similar in some ways. We're working from a sample and we're using something from the sample, a statistic from the sample, to infer something about the whole population. So that's the idea. Now, in previous questions, we used a sample mean. So we were getting a mean from the sample, from one sample, and we're using that to predict or infer the mean for the whole population. This time we're going to get a proportion from the sample. So a proportion that satisfies some criteria. For example, the proportion of students that get a certain mark in an exam. And we will use that proportion to try and predict the proportion in the whole population of students. So that's the difference here. So to emphasize the difference, I'm showing two simple examples here. For example, a sample mean question, which we've been doing, would be something like this. The mean mark of students in a sample is 70. What is the mean mark for the whole population? So that's what you're trying to figure out. You're working from the sample with that mean mark of 70%, and you're trying to use that to predict within a certain confidence interval what the mean is for the whole population. Now, look at the difference with a sample proportion question. So in this question, 70% of students in a sample passed an exam. So that's a different emphasis straight away. We're looking for a different thing. This is the proportion of students who passed the exam in the sample that you're working from. And you want to use that proportion to predict the population, the proportion for the whole population. So that's the big difference here. Now, it turns out conveniently, just like sample means, that the sample proportions will be normally distributed around the population proportion. And we just with some new notations and so on, we can work out confidence intervals in a similar way to what we did with the sample means. It's just basically a different formula, and that's about it really. So we're going to use the following notation from now on for these type of questions. The population proportion, we'll call it P. So let's take the example of, we'll say, the number of students in a class that got over, we'll say, 70% or something like that. Well, then P would be 0.7. You express it, that got over 70%. So P is the percentage or the proportion of students who got over 70%. P hat, as we call it, that's the sample proportion. So that's the proportion of students in the sample that you're working with, the proportion of those students who got over 70%. And ideally, of course, the whole idea is you'd be hoping that the sample you're working from, if you got a certain proportion, that sample who got over 70%, well, it should be the same proportion, hopefully, in the population, that sample is basically predicting the correct population proportion for the population. Now, it turns out without proof, you can use the following formula, the margin of error. If you use this sample proportion here to estimate the population proportion P, so P hat estimates P. If you use that estimation, well, you got a margin of error on both sides. And you can be 95% confident that the actual population proportion P is within that margin of error. And the margin of error is given by P hat plus or minus 1.96 times the root of the population proportion into 1 minus population proportion over n. Now, in reality, you're only ever working from a sample. So more likely than not, you will not have the population proportion P here. So what you can do is sub in P hat. So this is very often, you use the P hat in this formula instead of P. So I make that note down there at the end. So this is our new formula for our confidence interval. P hat plus or minus 1.96 times the root here. Another interesting feature of this is when P is close to 0.5 or 50%, and this can be shown by calculus, you can actually get what's called the maximum margin of error on both sides. What's the maximum margin you could have on both sides of the sample proportion P hat? And if you put in 0.5 and work through this, it ends up at 1.96 times 0.5, which is roughly 1, very approximately 1 over root n. So you get a simpler version of the formula, P hat plus or minus 1 over root n. So the margin of error is you take your sample proportion, P hat, and you go 1 over root n on both sides. That's how much error you're allowing on both sides for estimating the actual population proportion. Now, this simplified formula you can only use in certain instances, really. When you're in doubt, use the full formula. This is only an approximation. There has been one incident in an exam paper, 2016, question 9D, where you had to work backwards, and You were given the answer 1 over root n. The margin of error was equal to a certain number, whatever. So you had to work backwards. So use this formula, because if you use the other formula and work backwards with the root formula here, you had too many unknowns. You didn't have p, basically. So it would have been impossible to work out. So there was one example where you had to use the simplified version of the formula in an exam question. And that's about it, really. That's the theory of population proportion. There's not a whole lot involved in it. It's the same formula over and over again. The best thing we can do is look at an exam question for this. So if we take, for example, 2019, paper 2, question 8. So if we read this carefully, a motoring magazine collected data on cars on a particular stretch of road. So you're talking about 800 cars, data on 800 cars was recorded. So that's your sample size, 800, that's n. And we're getting the ages of the cars, we're recording the ages. 174 of them were new. So now we got a proportion in our sample. 174 out of the 800 were new. So that's your p hat, really. That's your proportion in your sample. So 174 over 800 is 0.21. If you work it out, it's 0.2175. And then you can get your confidence interval for the formula. So you can basically use that sample to predict all the whole population, which is, of course, all cars. So the Motoring magazine is basically collecting data on all cars on a particular stretch of road. So the whole population is all cars. The sample is the 800 that were recorded. So if we use our p hat here, so I suppose this should be p hat, really, if we were strictly speaking, given this proper notation. The population proportion is, or the sample proportion is 0.2175 plus or minus 1.96 times the root of, and you sub in your p hat as well here. So it's the same number subbed in over and over again, over the sample size, which is 800. And you get an end result of plus or minus 0.0286. Now, what you do with that is you work out, do those two calculations, the plus calculation and the minus calculation, and they give you the two extremes, or the two limits of your margin of error, basically. So that's your confidence interval between there and there. So you can go down as low as 0.1889 or up as high as 0.2461. So to summarize, what are we saying here? We're saying in your sample, 21.75% of cars were less than 1 year old, were new. So based on that sample, we're predicting that in the whole population of cars, in all the cars, somewhere between 18.89% and 24.61% of cars on the road are going to be new. Somewhere between those two limits. We can't say exactly because this is only a sample, but we can say with 95% confidence. That's what this is. It's a 95% confidence interval, and that's the only interval they can ask you in the Leaving Cert. It's always going to be a 95% confidence interval. So that's that question done. Just to look at another one, 2018, the previous year, paper 2. So part A was a sample mean, so we've done those. But if you go on to part B, you'll see again a similar type question. A company surveyed 400 people, so again that's your sample size, that's n, from the population of people who had bought at least one bar. So of those surveyed, 324 liked this new bar. So there's your proportion again. 324 of the 400 liked it. So that's a proportion now. 324 over 400. And that works, that's your p hat, your population proportion, your sample proportion, I should say. And that works out to be 0.81. And then you fill in the formula as usual, p hat into 1 minus p hat. So it's 0.81 into 1 minus 0.81 over the sample size, which is, of course, 400 up here. You get a plus or minus. And that's your 0.81 plus or minus this number here. And if you work that out, the plus and the minus, you end up with 0.77 up as far as 0.85. So again, what are we actually saying here? We're saying if the sample proportion is 81% of people like the bar, so 81% is in the middle here. If 81% like the bar in the sample we picked, well, that means in the whole population we can predict that somewhere between 77% and 85% of people will like this chocolate bar. And we can be 95% confident of that happening. Okay, so that's it. And then maybe the last thing to show you is that question where they asked it the other way around. So this was the one I was telling you about in 2016, the Part D. So it was a survey into the use of agricultural land, and N farmers were surveyed, but they don't tell you what N is, so that's the sample size. And the margin of error is 4.5%, which as a decimal, of course, is 0.045. Now, the margin of error formula that we have involves the root of p into 1 minus p. But we don't have p. We are not given p in this question. So you have to use the simplified version, as I showed you earlier, which is the 1 over root n simplification, because now there's only one unknown, and now we can solve it. So this is the simplified margin of error formula. So you can use 1 over root n. Here's the margin of error is 0.4045. Square both sides, get rid of the root, and so on. Turn it upside down first. Square both sides, and you get n is 493.8 or 494 rounded off. So you would need to sample 494 people, farmers in this case, if you want a margin of error of 4.5% on either side. So the idea is, so you need a sample size of 494, and that's the only one where it was asked backwards. Okay, so that's it. That's the end of the lesson on sample proportion.